right, so let's just kind of continue what we started on Wednesday. We're working on confidence intervals. We started that a while ago, and we talked about how there's two different types of questions with confidence intervals, right? The first section that we went over was talking about questions that gave us a bunch of information. The population standard deviation was given for those, right? The new set of notes, which are these, are questions that give us the sample standard deviation. Okay, so that's the only difference between this question and the questions in the last section. Okay, everything else that you do, like they're the same steps, but there's slight differences within the steps. For these questions, we're going to use the big chart instead of the small chart. And then the only other difference is that the standard deviation symbol or the standard error symbol is a little bit different than the standard error formula here. It's still standard deviation over the square root of n. You're just using the sample standard deviation instead of the population standard deviation, which is pretty obvious because that's what you're given in the problem. Okay. Now, I think what we did is, I hate doing this, but we left off at this example. We finished it, and then we kind of just left example 2 there. Normally, I have you like work on them on your own, but for the interest of time, I do want to do this together. Also, I just feel like it's been a while since Wednesday, and you probably don't remember how to do each of these steps. So let's just do it all together, and then, well, yeah, we'll continue on. Okay, so the hardest part of these questions is you're going to be given a huge paragraph. You're going to have to sort through the numbers in the paragraph and figure out what means what. Let's see. We have a sample of 123 people. I guess that's our size of our sample, right? So, all right, n equals 123. Okay. Age 18 to 22, they reported the number of hours they spent on the internet. The sample mean was 8.20. And what's the symbol for sample mean? X bar, perfect. X bar is 8.20. Then it says with a sample standard deviation of 9.84. I was going to ask you if it was sample or population, but it literally says sample, so I'll leave that to you. What's the symbol for sample standard deviation? S, perfect. 9.84. Okay, we have a bunch of other information in here, but the biggest part is that we're trying to do a 98% confidence interval. And the overarching question here is to ask, what's mu, right? That's what we're trying to come up with an interval for. All right, now, before we do our question, we can't actually do this if we don't have our assumptions, right? The first assumption that we have to ask ourselves is S given to us? And the reason I'm asking this is because, well, you'll see later that, okay, if S is given to us, we use the big chart. If sigma is given to you, use the small chart. Since we're using the big chart, we have to figure out if we can use it. S is literally given to us in the question, so we're good. Okay, I'll put a little smiley face next to it. Okay. The next assumption that we have to ask is our central limit theorem question, where we have to see if either our sample size is bigger than 30 or if there's something about the population being normal. My sample size is 123. Is that bigger than 30?
Yes.
Yeah, way bigger than 30. We're good. And we don't have to check if the population is normal. All right. Next, since S is given, well, now we can use the big chart, right? The big chart tells us the critical value. Before you use the big chart, though, we have to figure out the degrees of freedom, right? Because that tells us which row to use. What's the formula for degrees of freedom? N-1, right? It's the simplest formula in this entire class. You just plug in n, which is good that I wrote it up here. 123 minus 1 is 122. Okay. Now let's peek at our chart. On the degrees of freedom column here, it looks like we actually don't have a row labeled 122. So what do we do? What row do we use? 100, right? If the number is not on the chart, you look for the next lowest number. So like you kind of just round down and find the number on the chart that is closest, not closest, that is less than the number you found, right? And then that's the row you use. So we're using row 100. We're using the column for 98% because that's what we're given. Can we all agree that my critical value is 2.364? Cool. All right. Critical value is 2.364. Awesome. All right, let's flip the page over. Let's do the standard error. What is my formula for standard error? Perfect. I did it the opposite way when you said that, but standard deviation over the square root of n. Doesn't really matter if you want to memorize s over the square root of n or you just memorize it standard deviation, because either question that you get, same formula. Good thing that I wrote down all my information on the first page, because all I have to do is write down the numbers instead of parse through the question. S is 9.84. N is 123. I personally like to do the square root, write it down, and then divide. But apparently I'm being a hypocrite today because I did not do that in my notes, and I don't feel like doing that right now. So let's just say that when we do this, we get 0.887. That might not even be right. Who knows? But that's the number I wrote down in my notes. All right. Let's do the margin of error. Does anyone remember how to find the margin of error? Multiply, right? Take the two numbers you just found and multiply them together. CV times SE, right? I'm going to take 2.364, which we found in part B, and then I'm going to take 0.887, which I found in this part, and we get 2.097. All right. The margin of error, that's the thing that we want, right? That's the thing that tells us how big our interval is going to be. Now we can construct our interval. And the way that I like to construct it is, let's think about this. Okay, where is the interval going to be? If we're trying to figure out what mu is, the population mean, well, the closest thing to the population mean has to be the sample mean, right? It's probably not going to be exactly the population mean, but I'm assuming that the sample mean's got to be somewhere near the population mean, right? So let's just take my X bar and put that in the middle, 8.20. To get the upper number in my interval, I'm going to take 8.20 and add 2.097 to get 10.297. To get the number on the bottom, I'm going to subtract 2.097 to get 6.103. And there's a couple ways I can write my interval, right? I can use it, I can use the plus or minus symbol, 8.20 plus or minus 2.097. Okay, I can write it in interval notation where I put my lower number and upper number in the same interval and like clump them together. Finally, I can use the less than symbols, right? I can do 6.103 is less than mu, which is less than 10.297. Okay. Any questions on writing the interval? Finally, writing the interval in words. It is very important that you say this in the right phrasing. If you don't phrase it correctly, I might have to mark it wrong. I like just memorizing the template. We are, in this case, 98% confident that what we want, mu, is between 6.103 and 10.297. Okay, and that is how we do these confidence intervals. Any questions on these guys? All right, pretty simple. Yeah, I don't think it's too crazy here. All right. Well, that's the end of this set of notes, but I do want to add just one more page to it. Personally, I don't think these questions are that hard, okay? Like, each of the steps are either multiplying, dividing, maybe a square root in here, maybe remembering the template, but pretty much everything's pretty easy here. It is kind of hard to know what to do on each step, but I think the hardest part about this entire chapter is on the test, I'm not going to tell you what steps to do, okay? So I'm going to give you a big paragraph, okay? I'm not going to tell you if you're using the big chart or the small chart. I'm just going to give you a paragraph and you're going to decide if, like, okay, am I doing the degrees of freedom and using the big chart? Am I using the small chart? Which formula am I going to use? And I think that's the hardest part, because sometimes the word problem is worded like kind of tricky. And it's kind of hard to see, like, okay, do I use this chart or that? So what I'm going to do is I'm going to give you a couple of word problems. We'll do one together, okay? I'm going to have us decide, like, do I use the big chart? Do I use the small chart? And I'll show you some tricks that the textbook uses to tell you which chart you're using, even though they're not explicitly telling you. All right, so we have a new set. So I kind of mentioned that the hardest part of doing these problems is, given a problem, trying to figure out, like, okay, which chart do I use in this whole situation, okay? Now, does anyone remember, like, the difference between the two problems in these sections? Sophie?
One was sample and population.
Yeah, right. There's a difference between the sample and the population, right? So sample versus population, okay? And not just the sample and population in general, but the sample standard deviation and the population standard deviation, right? That's the only difference between the first section and the second section, okay? Now, in the first section, we were given the population standard deviation, or sigma, and in that case, we use the small chart, right? Small chart, okay? And in the second section, we're given the sample standard deviation, or S, where we use the big chart, okay? That is the only difference between the two problems. If you're trying to determine if I use the small chart or the big chart, just look at the standard deviation, figure out if it's the population or sample standard deviation, and that tells you what chart to use. Now that seems pretty easy, but I will say these questions are kind of tricky, okay? The textbook loves to write questions that I don't know. They don't tell you if it's S or sigma. You have to read the question and figure out if it's S or if it's sigma. And there are some like common ways that the textbook uses for this and that the final exam uses for this. So I want to kind of get used to reading these questions and figuring out like, what do I do in each situation? Okay, we're going to do number one together, and then I'm going to let you steam on the rest of them, okay? Number one, during a study of body temperatures, a bunch of temperatures were taken, okay? Suppose that we only have the first 10 temperatures to work with, okay? Since I'm given 10, well, that's the number of things, right? If you're wondering if it's the sample size or the population size, these questions only give us the sample size. So whatever number you're given, that has to be what n is, right? N has to be 10 here, okay? So at this point, we know that our sample is those first 10 temperatures, okay? The mean and standard deviation of these 10 scores were 98.44 and 3.3 respectively, which means that like, okay, the mean went first and the standard deviation went second. Oop, so I know that my standard deviation is 0.30, okay? Now, who thinks this is the population standard deviation? Who thinks this is the sample standard deviation? Oh, we have more hands for the sample. Anyone want to describe why it's the sample standard deviation? Timothy?
Well, because it doesn't reference the population in any way here, and it's specifically talking, it says we only have the first 10 temperatures to work with, so it's implying there's no other data outside that we're working with.
Yeah, nice, right? If it's not really talking about the population here, right? And since n is 10, n is the sample, right? So the sample is those 10 temperatures. So even though it's not saying that the sample mean and the sample standard deviation are these two numbers, the 10 scores is the sample, right? The 10 scores consist of my sample. So it's basically saying that it's the sample score, or that it's the sample mean and standard deviation, but it's saying the 10 scores instead of the sample. Does that kind of make sense? Okay, so this definitely is the sample standard deviation, S. And if S is given, do we use the big chart or the small chart? Big chart, right? Big chart always goes with S. Use the big chart here. Okay, so before you do any of these questions, you basically have to read the question, figure out if S or sigma is given, and then that'll tell you, okay, like, do I do the big chart process or do I do the small chart process?
Wait, so this is sample, so we're using big chart. Okay.
Yeah, I know it's kind of confusing. You would think sample small. Okay, so I have 4 more questions for you. I have 2, 3, and then if you flip to the back, we have 4 and 5. I want you to steam on these. And if you get these wrong, don't feel bad right now because I haven't told you the tricks that the textbook uses to tell you if we're talking about the sample or population. So if you're a little confused, it's totally normal. I'll tell you the tricks after we steam on this for a little bit. Okay. Wait, let's go back up to the front. I just wanted you to steam on this. If you got some questions wrong, it's not a big deal now because I didn't tell you the hints that the textbook likes to use. So let me tell you some hints that the textbook will use to tell you if it's population or sample standard deviation. I bet you didn't expect an English class for math, but here we are. So we have the simple random sample of 36 St. Bernard's dog weights, which is a very random question. I guess n is 36, okay? This random sample yields a sample mean of 193 pounds, okay? So that's, well, the sample mean. Then it says, it is known from previous studies that the standard deviation is 18. So in that sentence, we have this phrase that says, it is known from previous studies. Whenever you see that, that's the textbook way of saying that, okay, we're talking about the population now, okay? Actually, in our textbook and on the final and on the test, all the questions that we can use for this class, if you see that it is known from the past or from previous studies, that's like the number one hint that we're talking about the population. So what are we getting for the standard deviation here? Population or sample? Population, right? That it is known from the past, talking about the population. I will say that sometimes it does say in the paragraph, it is known from the past, and it still can be the sample standard deviation. The biggest hint that this is the population is because it says that it's known from the past in the same sentence as the standard deviation. So you have to be a little bit more careful than just looking at it's known from the past. If it's in the same sentence, then we're talking about sample standard deviation or population standard deviation. There we go. All right, any questions so far? All right, which chart are we using, big or small? Small, perfect. All right. So that's one hint that the textbook gives. Let's look at number 3. We have scores on exams and statistics have a normal distribution with an unknown population mean and a standard deviation of 3. Now at this point, it gave us the standard deviation, so I'm not even going to read any further, right? I have my standard deviation, it's 3, okay? Who thinks population standard deviation? Who thinks sample standard deviation? All right, anyone who said population want to explain why? Jim?
So it says suppose scores on exams and statistics as a whole are normally distributed.
Uh-huh.
It also talks about an unknown population and then references standard deviation, which makes me think that they're still talking about population as well. It also says confidence, define the confidence interval for population.
Yeah, actually, yeah, that bottom sentence will always be the same, but I like your beginning. Yeah, right. When it talks about the population in the same sentence as the standard deviation, that's a big hint that, well, this is the population, right? I'll give you one more hint that this is population standard deviation, okay? So that's a good hint. The other hint that I would say is after we introduce the standard deviation, that's when the sample is introduced, right? So we ended talking about the standard deviation. Then it says, oh, we took the sample of 36 scores and found its mean, right? So when we talked about the standard deviation, we haven't even started talking about the sample yet, right? So if we didn't introduce the sample yet, how could 3 be the standard deviation of the sample if we haven't even talked about it yet, right? Okay, so small or big chart? Small. All right, so to recap, right? Small chart is the population standard deviation. Hints for the population standard deviation is if it says it's known from previous studies in that same sentence, right? If we're talking about the population in the same sentence, or if we haven't even talked about the sample yet, right? So 3 big hints that we're talking about the small chart. Let's go to the back. We have the National Center for Education Statistics. They surveyed like 4,000 college graduates about how long it took them to get their degree. The mean was 5.15. The standard deviation was 1.68. I'm going to do a confidence interval for this, okay? Now, I think this is probably the trickiest one in the whole paper here, okay? Well, the standard deviation is mentioned here, okay? Now, what were you getting for this one? Sample or population? Sample. It actually is the sample. S is equal to 1.68, okay? Now, there's a couple hints going on why this is the sample, okay? Now, we surveyed 4,000 students, right? So 4,000 is the size of my sample. Those 4,400 students, that is my sample, right? So if we're talking about the sample and then immediately going into the mean and standard deviation, then we're still talking about the sample, right? Okay. The second hint here is we're given the mean, right? 5.15, okay? Whenever you're given the mean for questions like this, it's always the sample mean because we're asked about the population mean. It would be really dumb for the question to tell us the population mean if we're trying to find the population mean, right? So 5.15 is the sample mean. So if we're talking about the standard deviation in the same sentence as the sample mean, this has to be the sample standard deviation, okay? So which chart are we using? Big chart, perfect. Okay. Last one, I wanted to know the average amount of steps people took per day. I took a sample of 14 people, asked them how many steps they took per day. The sample mean was 3520 with a standard deviation of 300. Okay, so now it's not telling us if the standard deviation is sample or population. Who thinks population? Who thinks sample? All right, so we're kind of split here. I'll actually tell you that this is the sample standard deviation. Anyone who said sample want to explain why? Michael?
Because it says the sample mean and then the standard deviation of the same sentence.
Yeah, is that what you're gonna say too? Yeah, so whenever we're talking about the sample mean in the, or sorry, the standard deviation in the same sentence as talking about the sample, these questions aren't gonna get too crazy, okay? If it's in the same sentence as talking about the sample, this is also the sample, okay? So big or small chart? Big chart, perfect.